I am super excited to be joined by Oscar from Nyckel today. This is kind of a cool thing. Oscar, I haven't talked to too much, but we bring in people, service providers, experts, accelerator admins, investors, whatever, to our audience on a frequent basis to share stuff that startups care about. And most of the time it's like corporate back office stuff. How do safes work? How to get, non-dilutive financing from, service providers like that. But today is a really cool one because I have an engineering background. We have a lot of engineers in our company, and we stumbled upon Oscar's company called Nyckel, which does makes machine learning available through, I will say, a very elegant API. And Oscar was gracious enough to spend some time with us to kind of explain how startups can benefit from this technology without necessarily having a bunch of PhD computer scientists on their team. And so Pete, our CEO, we both led an integration to actually use Nyckel services a couple weeks ago, maybe even honestly, it could only be weeks, but months ago, to help us solve a content problem, which I will get into detail towards the end because I want to give most of the stage to Oscar. But we had such a great experience that Pete felt compelled to reach out and see if he would come introduce kind of their product to our audience, as well as talk about machine learning in general and how startups can leverage it. So I'm going to let Oscar take it away. He's got some cool stuff to run through us. As always, I will serve up any questions or relevant things throughout. So please use the chat, use the Q&A, and I'll jump in and interrupt if there's something relevant. And without further ado, Oscar, take it away. Give us a little bit of your background as well and the history of the company, and you know what to do.
We'll do that. Thanks a lot, Ryan. Thanks for the introduction. I actually can't share my screen. It says that I can't share a screen while the other participant is sharing.
Now you should be good.
Now I can do it. Excellent. Thank you. All right. So are you seeing my presentation now? Okay. Like Ryan say, I rather, have this be as interactive as possible. So please do just raise your hand or say something in the chat, and I asked Ryan to just interrupt me and we can take questions throughout. Yeah, let's get started. So just briefly about me. I'm from Sweden. I have a master's in physics and a PhD in computer science from UC San Diego. I've done this for shipped machine learning products for about 20 years. So I did it before it was cool. I've also done a fair amount of research. I have like 5,000 plus citations on my academic work, mostly on object detection, domain transfer, those kind of things. And I've also run recently a pretty large team of about 100 engineers at one of the big self-driving car shops. So some of the stuff I worked on are on this screen. So I've done, machine learning for microscopy, actually an autofocus system for microscopy. I worked on that airbag bicycle helmet in the bottom right, where I actually build the AI to detect that you are in a bike accident sort of as you're flying through the air. So that was kind of a high stakes startup in Sweden that I took on right after I graduated. But it's in production and sold throughout Europe and I think in Japan.
When was that around? Because I've seen that same technology get extended to motorcycle suits.
Yeah, so there's, as far as I know, the motorcycle ones you plug in to the motorcycle, you have a little string.
It's like a treadmill.
Yeah, exactly. And there's also versions for nowadays for like downhill skiing, for like surfing even, and I don't know. I think everyone operates a little bit differently, but we want it to be fully automated. And of course, we have to limit it to you can't go take your. It's for like everyday biking. It's not for mountain biking and BMX and so on. But yeah, and then during my PhD, so the bottom center here is for I developed a cycle coral net that helps scientists automatically annotate their data. So like you see this is the bottom of the Caribbean, and they want to try and figure out what's down there. So the way you do that is physically you dive down and take pictures. And then they typically only care about percent cover of different types of things. So they do random sampling. So they randomly scatter these spots on the image and look what's there. And that's an insanely tedious process to do manually. So my whole PhD was about automating that. And then most recently I worked on, this is a vehicle from Hyundai. So the company I work for is called Motional. And we tried to solve the self-driving car problem basically. So I ran the machine learning team there with about 100 engineers across, modeling, infrastructure, data, and so on. And most recently I founded Nyckel with some friends. So just quickly about Nyckel. So it's an API for custom machine learning. And I put the word custom in there because when you say just machine learning, there are a lot of APIs we say. There's a lot of APIs out there for pre-canned models. So I want to detect faces in this image. And there is 10 or 20 or even 100 possibly to choose from. But what we try and do is make an API that lets you custom or tailor the endpoint to your data. And that's a little bit trickier to get right. It's a little bit more complex. But, I think it's basically the only way to do it in many situations. You can't rely on pre-canned models in a lot of situations.
Is that because these other situations are mostly they've already trained up the thing on the kind of data set that you're targeting on? So it's it's facial recognition, but you can't use it to recognize cars because it's biased towards the previous training and whatnot.
Yeah, I mean, it's problematic in a lot of ways. So one is, like you said, the output categories. You have to there has to be a match between the output categories they use when they train the model and that you need. So faces is a good example because it's a very generic one. Okay. But if you want to do, and there's Google has an endpoint called Google Vision API, and it gives you a set of sort of common objects in images. But if your product, for example, one of our clients are interested in, are plants wilting or are they not, right? Mm-hmm. That wasn't part of Google's pre-training, right?
Right.
And I can give you 30 more examples like that. And when it comes to text, I want to spam, you can find generic spam filters, but the reality is that spam looks different for every platform. It has their own characteristics.
Yeah.
So yeah, those kind of reasons. So these are my co-founders, Dan and George. So Dan is our CEO, and he's also he built the APIs. If you like the API, good work, Dan. And George is our cloud backend infrastructure guy. And I quote unquote run the machine learning team, which is just me right now.
Oh, really?
Yeah.
That's impressive.
Thank you. Okay. So, what I'm trying to find strike the right balance here. And maybe we can start with a little poll, Ryan. Can you ask people to raise their hands if they have implemented a machine learning solution before?
Yeah. Please either raise your hands or do in chat. All right, so Paul Atkinson did. I will see if I can create a super quick poll with fancy Zoom technology. You're asking implemented machine learning, right? So
yeah, or just played around with it.
We have recently gotten much better at Zoom, but I'm still not using all the things. Let's see if this actually works. There we go. Did you even get the poll, Oscar?
I did not get the poll, but hopefully the other guys did.
There we go. Yes.
Oh, no, I see it. Okay.
There we go.
Okay, I'll reply yes then. Oh, I can't vote.
Oh, you have Oscar? Interesting.
Okay, I can't vote. That's actually better.
Oh yeah, neither can I. Darn. Oh, look at this. Hey, we're actually 60-40, but 40% yes.
Okay.
Oh,
that's
now
good.
33%. Yeah.
All right, that's a good
1/3
mix.
now. Yep.
All right. So what I'm trying to strike a balance between making this. I don't want to make this about Nyckel only. Obviously I want to make some sort of pitch for the company because I think it's valuable, especially for startups. I think it's a valuable way to move forward. But I also want to give a little bit of broader view on machine learning. If you guys are since we're here. So I want to start with sort of the good, why machine learning is wonderful, and then talk about the reasons my machine learning is not so wonderful, and then sort of look at how services like Nyckel can help, and then talk about some use cases, and if I actually end up with the seeing what Gust is doing.
Yeah, I'll promote the hell out of Nyckel at the end of it. So you can be as modest as you want throughout.
Yeah. Okay, cool. So the good news, right? So neural networks they are universal function approximators. And what that means is that given enough data, they can learn any function. Okay, so that's pretty amazing, right? So you write code, and a function here, I mean, really like any function that you write, you would write code for. You can learn, in theory, any function using machine learning. So that in itself is very, very nice. And what training does is you can think of it as compiling data into an executable that you can then run. And improvements are cheap, right? In theory, you just pump in more data, you recompile, and your performance improves, right? So that's different than traditional code, obviously. And I think the good news also includes stuff like there's a very fast rate of improvements in neural network designs. Like new ideas come up all the time from academia and the leading, AI houses. There's a lot of pre-trained models, a lot of a good culture of sharing, I would say, even from some other companies. Some are not so good, but others are. And the tools and libraries are getting better all the time. Okay, so we're actually 69 now. Okay, yeah. and 31 yes. Okay, great. Yeah, hit me with questions if this gets too theoretical or too weird. But I'm trying to strike the right level here. So what I want to talk about now, sort of the main part of the talk, is a closer look at the training. So what do we actually do when we train a neural network? Well, what we do is we're given a set of data, we're minimizing an objective function, and we're doing that by finding a optimal set of parameters or optimal values for a set of parameters.
Can you give us, can you explain what minimize an objective function means?
Yeah, so it's like from, I guess, optimization theory. So you have an objective function, and the objective function, it could be stuff like, how do I explain that? Is
it like it's objective?
I mean, it's just the way you post this. The way you post the learning problem is to say, given all this data, I'm going to basically have a function that I'm trying to learn, right? And I'm going to look at what this function does on my data, and I'm going to measure how well it does. And the measurement of how well it does is the objective function. And I'm going to try and get that to be as good as possible. And I do that by tuning the parameters of the model.
Gotcha. Okay. So the objective function is, if you think about like a function that you're going to ask a question of to determine something, right?
Yeah, ultimately that's what you're doing, right? You train in the case that this neural network is the hot dog or not, right?
Right.
So the objective function is like, given a hot dog, I want it to say yes.
If it's a hot dog.
Right. And I measure my objective function. The performance of my thing is measured by like comparing the output of the prediction to ground truth data. So I know, like, the annotated data. So I want to try and break this up into 3 pieces and talk a little bit about the challenges. So let's just start with the data. So given a set of data. So first of all, let's look at this example here. So I have these 2 cups and I have these 2 plates, and I give them to a model and say, the two cups are in obviously one class, and the two plates are in another class, and I train it. Okay, what happens then when I give it this blue mug, right? I want it to say mug, but it might actually say plate because it's blue, right? So there's like all these biases that we bring as humans on like how to group things, and there's the like sort of inherent or bottom up grouping that the neural network does that might not align with what we're doing. So that's sort of part of this concept of mining for hard samples. So it's typically not enough to just pick first set of data to train on. Sometimes it's enough, but a lot of times you need to go back to your data source and like keep finding samples that are informative and that like sort of challenges the model. So that's one thing. Another thing is this concept called concept called domain shifts. So it means that as the data changes over time, and that can actually happen even for stuff like spam filtering. Say train a spam filtering function, and then it works really well on like the data you're seeing in January, February, March. But then in April, like a new spamming agency sort of comes up and start throwing out completely different spam. Now that changes your data distribution, and it will likely change the performance of the model. So that's something to keep in mind, both before you train, so that you have like a sort of a nice sample from all the domains you already know about, but also post deploy, so that you're sort of continuously monitoring for that. And then there's the more like mundane issues of managing train validation and test sets, because if you're not careful on how you manage that, you could you have problems with overfitting and underfitting, and I'll talk a little bit about that later. But yeah, so those are some concerns about data. Any questions on that, or any thoughts from the audience?
It's funny to break it down in this, because as we were implementing it, on a long enough timeline, I'll ruin the story, but we used Nyckel and machine learning to help us with spam filtering. People were, creating profiles on our site that were for just SEO traffic. So gambling sites, adult content, a lot of plumbers and pipe fitters for whatever reason. But, we as human beings put in spam filters and experienced our own domain shift, not as a machine learning algorithm, but as like a human being. They're like, oh, people are spamming with this. Well, let's make it more difficult to publish a profile. And then a couple months later, the spammers have figured out how to get behind our, difficulty, and they've started putting in fake data in areas that they weren't before. And it's like, oh, well, now we have to do some other thing. And eventually we got to the point where it wasn't worth trying to outfox the spammers with our own human brains, and actually using the machine learning was actually helping us keep up with domain shifts.
Right. Yeah, and that's a pitch I made a lot to, back when I worked in industry for self-driving cars. It's this wonderful thing of like, say, take a self-driving car, and it has some issue with how it performs in a certain situation. If you rely on a quote unquote like engineering method or programming 1.0, you basically have to innovate yourself you have to rely on your human brain to like figure out how to improve in that situation. And as you're making that improvement, you may inadvertently mess up another situation, right? So innovation sort of comes at a very human cost, and it's expensive. Whereas with machine learning, that's sort of the pitch I made initially, where you can innovate, quote unquote, by just adding more data, or you can improve. You don't have to innovate the same way. Okay, so let's look at the second part. So the objective function. So the objective function, there's this concept called convexity, which means that a convex function has a single minima, whereas a non-convex function, you see on the left, it has several different minima, right? And the way optimization is done in neural networks is called gradient descent. So you're basically looking at where are you on. Can you see my cursor, Ryan?
Yeah. Yep.
Like, I am right here on this surface. What's the direction of down? So I calculate down and I move in that direction, and then you keep moving and moving and moving, and then you end up here, right? So you end up in a local minima where you can't get out of. But if you somehow magically knew of this other valley over here, you could get a better performance. So it is the case, and it's not the case for all machine learning. There are methods, for example, support vector machines famously have a convex optimization. So support vector machines.
I was going to say, what are those?
I guess a little bit of history. Like in the 90s, there was this the first AI revolution with neural networks, and everyone's really excited about them. But they were really hard to analyze theoretically. There was basically no math to explain why they worked, or very weak math. So this other family called kernel methods, and support vector machines is sort of the foremost example there, had a very beautiful mathematical formulation, and you could prove a lot of properties around them, and they tended to perform just as well as neural networks. So it sort of became the preferred method. And one of the properties they had was this convexity properties, which means that if you train it twice, you get the same performance, which is kind of nice.
That's very nice. Yeah.
If you train a neural network twice, you don't get the same performance.
Right.
So basically, because it's not convex, you have a whole set of, you have to worry about a set of stuff like learning parameters, like how do you set the, learning rate schedules, various dropout, like various things to make it behave as smooth as possible, like sort of as convex like as possible. So that's one set of issues. The other set of issues is actually the first thing I said, where you have to define the objective function, right? It's not like that's a given, right? You have to say, how do I actually express what I want this function to do in a mathematical way, and in the right mathematical way, because it really matters, right? So in the case of classification, am I optimizing for the total accuracy, or am I optimizing for the accuracy in a class balanced way, right? That's one example, and it gets much worse from there.
But you still have jobs.
Yeah, again, I don't want to I don't want to like people, I know most people in this call are probably entrepreneurs, so that's that's the main focus of building a business. But if you want to get into machine learning, it's not like I'm trying to tell you not to do that. I'm just trying to tell you that it's set aside like a year or two, right? And like try and
it's not like going to learn Rails as a founder because you want to build a web app and you can't hire an engineer yet, and you spend a couple weekends just getting some basic things up. Like there's a depth to the field that
and if you're lucky, that the simple thing works and you can kind of that'll hold you off for a while. But there's a lot of pitfalls. Okay, so then we get to the actual training part, which is finding the optimal parameter values. So fundamentally, there's this concept of like underfitting versus overfitting. And what that means is if you have this toy data here with the circles and the x's, and I think if most people here squinted and said, well, if I have to draw some sort of boundary, I would draw something like this. Right. And so these two x's are on the wrong side of the boundary. That might be because they are mislabeled, or they're just freak data points, and I'm going to have to deal with them some other way. Right. If I'm underfitting, I'm making too many errors for no good reason. And if I'm overfitting, it basically means that I'm doing perfectly on my training data. However, when I look at more data, when I deploy, I'm going to do actually worse, because I have sort of paid too much attention to these outliers. So.
Yeah, I think of that as something like if you're trying to do image recognition and you're trying to find the border of somebody's like face towards the background or something like that. It's like the fact that they might have a strand of hair or something like that complicates the border on a couple images, where those X's are actually part of the person, but like they're darker than their skin because of the piece of hair. But as you feed more humans into there, and the machine learning algorithms like, oh, humans have hair, sometimes it occludes parts of their face near the border, and then it gets better and better.
Yeah, exactly. So that's one concept. And then, so that's something you have to keep in mind when you train. You have to, again, manage your train and validation split and test split carefully, so you don't pollute and sort of overfit to the data you already have labeled. Perhaps the worst problem is that there's a combinatorial number of parameter sets, network designs. So,
for the non-discrete math of people in the audience, what does combinatorial number parameter sets mean, and why is it a bad thing?
Yeah, so it just means, if you look at the, even if you take a single network architecture, like residual networks are the most, I think still the most used ones. They provide like a template or a shape for how you should compose the layers of a neural network. But the reality is that you can change all aspects of that. So you can add more layers you can add more sort of kernels in any of the layers. You can make the kernels wider, you can make them deeper. You can change the network in so many ways. And it's combinatorial because there's like, you can do the search space is like, you have to search, you can change one thing and then another thing. So imagine you have like change 3 things, but then you can change all 3 at the same time. So the more of those axes you add, the more like exhaustive it becomes, right? It grows exponentially.
Yeah.
It's not
linear growth.
Right. And then you're basically just screwed. There's no way you can try everything. Right. And then to make matters worse, the machine learning, the theory, like I said, back in the 90s, they were complaining, we abandoned neural networks because there was no good theory. That's mostly still the case. So you don't really know. There's never, very rarely, like a theoretical, some theory to rely on. So you're basically relying on two things. One is trying things as quickly as possible. And to do that, now you're in the business of building out like GPU clusters and start like monitoring, tracking experiments, managing the models that you just trained. And again, like now you have to be really careful about like your train, test, and val splits, because if you run enough things, you're going to start like sort of bleeding into the train or the test and val sets. So you can rely on that, or you can rely on basically experience. People that have done this for a long time, they can usually squint at a set of experiments and say, you know what, try changing that thing, right? And it's just like it's completely just using the human neural network to like bootstrap the search space.
And this all sounds like it can become very expensive, both in terms of cycles, Amazon bills, time spent looking and squinting.
Yeah. And it's also, there's like, I mean, I don't know if that would be a risk if you're like a founder, because you don't have the luxury of spending too much time on this, but it's a real issue when you start hiring like a machine learning team. So if you hire like too many sort of junior people, I would say they're going to spend all time here, and they're going to just kind of get stuck in this loop of like searching for the right neural network, when they probably should be doing other things like talking to the customers about getting more data, or like mining for the right data. So there's like both a how do you do this right, and also like how do you not spend too much time on it problem. So anyway, okay. Any questions on that?
Not yet. I think you're setting us up to realize like there is, I mean, this is the whole industry here, an elegant depth and a complexity to it. But
right. Yeah, exactly. Yeah. So if you get to the bad news, so this is actually a schematic someone on Reddit put in the Learn Machine Learning subreddit. So you can look at that link. I can share it. So this is a set of services that solve some of the issues that I just discussed. So if you start from the top left, you have PyTorch Lightning, which is a framework for training neural networks, the actual core libraries. Then you have weights and biases that helps you monitor experiments like as they're running, to avoid getting stuck in a local minima, or like your just learning goes off the rails. But also to compare experiments to see, okay, I tried these things, they did so and so well, so let me now try the next thing. You have configurations. You have Hydra, which is a toolbox for managing your configurations. Because again, there is a combinatorial design space. So your configs, like your experimental configs, become very long. Like you just have these endless. You can basically, the whole neural network architecture is basically a configuration. You can change any aspect of that. So you need management of your configurations so you don't get lost there. Okay, so then you train your model, and then you convert it to ONNX. I don't know if that's always necessary, but this person seemed to think so. ONNX is an open, like kind of a open standard for how you describe the trained networks. Okay, and you put that in S3. I think that makes sense. And then you need your like CI pipeline, right? So you fetch the model, you build the Docker container, put it in some runtime, and then once you have the Docker container, you need some way to update your Lambda function, and some API gateway that lets the end user talk to the Lambda. So now you basically have deployed your thing. But then you also need, obviously, on the other side, the post-deploy thing, you need like some way to log, some way to search the logs, and then all these dashboards to monitor what's going on. And obviously monitor for errors, but also, like I said, monitor for data distribution drifts, and a kind of alert on that sense. Yeah, so
it's a lot.
So it's a lot. It's a lot. And actually, if you think that looks bad, as I was looking at this yesterday, I realized there's actually a lot of things missing. So what they put in this top box here, I think this is a great understatement, because unless you have, I would say, in all situations, unless the problem solves itself like in a day, you're going to need some like distributed parallel compute for training, because otherwise you're trying one thing at a time, and it's just your life gonna be very tedious. So Grid AI is a provider of GPU training compute resources. Determined AI is another one. It's actually an open source toolbox that lets you sort of provision your own on AWS. I use it myself. I think it's neat, but it's definitely it's not like an out of the box type thing.
Right.
You might need an annotation workforce to label your data. You'll certainly need an annotation tool, like whether you do it yourself or some way to like just look at your data and say, okay, I have this image, and this is the label I've associated with it. If your model gets more sophisticated, you need something like data mining and discovery. Again, finding like, okay, I've annotated these 1,000 samples, and now I want to annotate 200 more. But which 200, right? It's like I have 1 million samples in my database, but which one should I spend time annotating, right? And that's what like Aquarium Learn has made a business out of. And then finally, last but not least, is archive, right? So the field is moving so quickly that if you're not staying at least somewhat atop of the literature, and nowadays, like if you're on the right Twitter sphere, you can get a lot of the news there.
Right.
But that's also important, right? So all of these, I think these 4 boxes go into basically this first step, what they call week 0.
This reminds me of, I'm sure you're probably familiar with Heroku, but I grew up in my like early engineering days doing web development.
Right.
And so it's like, oh, the LAMP stack. So you have to download this, and you have to do this, and you have to install the database, and this and that. And then it's like, oh, but now, even just seeing Docker there and being like, just Docker is like, there's so much complexity there. But it's turtles all the way down. There's just so much infrastructure to put up and maintain and be familiar with, and those weeks are probably generous. Or conservative.
This is sort of assuming you know what you're doing and you know what to look for, even, right? So no, I think that's an excellent comparison. I mean, we like to think of ourselves as a bit of a Heroku for machine learning, in that sense. It's one of the companies we're inspired by.
Yeah. I like the original Heroku website, or like right before they were really starting to grow. It's like they had a picture like this, and there was a slider, and you could drag the slider, and if you drag it to the right, it replaces the whole thing with like 3 states. Like it's like code, deploy, production. And it's like, and that's what it is. I mean, Heroku's still like, if I was to start a brand new startup and I was going to do dev stuff, like I would probably defer the Amazon bills and the containers and the Dockers and all that, and just be like, get push HTTPS Heroku.
Yeah. No, I think, that makes a lot of sense. So I guess this is my attempt at the slider, not having a designer in-house, but so the Nyckel API, it basically has these 3 steps. So you define your function and your label. So the function could be, okay, it's like a template, like I want images to be the input and classes to be the output, or I want text to be input and something else to be the output. And then you just add your data. So either you put in your data and your labels, so you have them, or you just put in the data and you can annotate in the UI. And we help you with like the stuff I mentioned about like active learning, like promoting the samples that we think are going to be most important for you to label. And then that's it. So there's no calls for training or deploying or managing on models. That's just, we don't expose those things at all. So as soon as you post your last data sample or like annotate your last thing, we immediately retrain and redeploy for you and put it up for on a stable endpoint. So that's sort of behind the scenes, right? So we learn from new data, and we really optimize the training to be fast, so we can actually learn in seconds. The first training typically takes maybe a minute if you have a lot of data, but other than that, it can go down to just 2 or 3 seconds. And what we're doing in that time is trying thousands of models on your data in parallel. And we evaluate using something called cross-validation. So that's where you kind of, it's a little bit tedious, but you split your data in many different small pieces, and you like train on one and test on the other one, and you
Oh
rotate
yeah.
through.
Like a permutation testing where you just like, what if we scattered this all differently and trained
Yeah,
again? Very
exactly,
cool.
exactly. So it allows us to not as the user to define my like train and val. It's just one set of data, and then but you're still not going to overfit because you're doing this cross validation. And then we find the best model and we deploy. And again, here we sort of took the liberty of defining the objective function on behalf of the customer. So like, they don't know exactly how we choose the model.
Mm-hmm.
And we're going to keep it that way until someone really complains, because we found that we actually had in the alpha version more things. We exposed more things, but we found that it just makes it confusing and like sort of stressful, because the more things, the more dials you see in the UI, the more like stressful you get about like, did I set them correctly?
And I will say, and this is like a great takeaway just for startups in general, especially like often when you're an expert in your field and you're building software around it, like, all these things. Like this is the weirdest parallel, but like we do Delaware C corporations and cap table management for most of our customers. There is so much information I am excited to talk about like why 10 million authorized shares, like how vesting schedules work, like why you wouldn't want to like sell shares directly to investors, but like to load all that information up front literally terrifies people or just makes it like, no. Instead, it's like choose smart defaults, make it as frictionless as possible, choose the good smart defaults. And then when it gets to the time that later on, it's like, oh, I actually need to know and learn more about this and care about this. You're giving them like contextual bite-sized information. Because everything is infinitely deep these days. Like the fact that this all runs on electricity, just passing signals between silicon on somebody else's computer somewhere, is like the thing from a couple of decades ago. It's pretty wild.
Yeah, you're right. It's all about layers of abstraction. So, and then obviously what we also do is the SaaS convenience that we're all used to. So all the provisioning, all the uptime, the cloud data store, those kind of things. And then the data discovery, I think we're doing some things. Like I said, in the UI, you can filter on where are my models doing, what data samples are my models doing poorly on, and poorly on with high confidence. So you can sort of see the kinds of errors it's making and add more similar data to try and fix that. And we're also working on like sort of the stuff I talked about with post-deploy, to monitor post-deploy if your model seems to be struggling.
Drifting.
Yeah. So that's it. I was actually going to jump into a quick demo, if that's all right.
Yeah, please. I think that'll help solidify, because this makes a lot of sense to me because we went through it. I will say, like, and I hope you show it here, and this is like me showing my old developer nerd stuff. Integrating with this was one of the more exhilarating technical experiences I've had in a long time. And I will actually put that in a couple of years. It's like we're living in an age of startups where people are putting apps out and doing things, and like they're, one innovative thing comes along and then people iterate on it like crazy. And you get to the thing of like, oh, like test message, login URLs. Like, oh, I guess this is the thing now. Pete and I together loaded, I think, 2,000 or 4,000 data samples of spammy looking startup profiles into the machine. And we already had data on them of like, this is good, this is bad, because we have hundreds of thousands of millions of companies. We just took a subset of them, loaded them into Nyckel, and watched that bar just creep up and learn. And we were so excited. We were like, is this going to work? Like, and then we like threw a couple profiles at it as soon as it was learned. And just getting the results back was like, it was thrilling. It was absolutely nerdy, super geeked out thrilling.
Well, thank you so much. So just briefly, the function types, like I said, we support for text. You can classify. We also have a search things. You can actually put in your whole text database, and you can search by putting in a new text string, and it's a semantic search. So it's like fuzzy. It doesn't care about spelling, and it knows about synonyms and all that good stuff. And you can also just put in an image. Actually, you can search your text database using an image. And then for image, we do the same thing. So classify, search, and now you have an image database that you can search with other images. or just text. We have an OCR, and then we're launching this localization thing where you basically find things in images. So it's sort of a more sophisticated image.
Oh, I see.
Product. Instead of talking about the whole image, you're talking about like locations in the image.
That Coral experience must have paid off there.
Which one?
Your
exactly.
experience with the Coral.
Yeah, I mean, that's my whole career was like the last 10 years I've been doing detection. So hopefully I was able to do something useful there. It's in private beta and we're seeing good performance, but it also always going to depend on the data. So let's do one. I have one, like a set where we do like mask, like sort of a timely mask classification.
Yeah.
If people are wearing masks. So we're going to have a mask class and no mask class and mask incorrectly worn. And this is an example where, I mean, maybe nowadays there are pre-trained models for this, but obviously when this all started, you couldn't find like a pre-trained mask classifier on the internet.
Who would have needed one?
Right. I hope we don't need one again soon. So let's see here. So what you do first is just upload some data. Okay. And I'm just selecting them in my desktop. And optionally, when you import, you can actually just assign the label here. So I'm going to, just for expediency, assign these to the mask. So you see they are being uploaded and populating this mask category. So let's do one more.
Oh, so that was data that was just all people that you know were wearing a mask.
Yeah, this is basically my training data that I had on disk. So I know none of these have a mask here. Import and then pop.
Yeah, these are the levels that were very exciting.
Yeah. Yeah. Man, I hope, unfortunately, I think Dan is on the call. He's going to be very smug from all the nice things you're saying. That's all him. Okay, so then to make it a little bit more interesting, we'll say this like incorrectly worn. So like I'm wearing a mask, but it's not correct, right? So import some of those. And then you see like, we actually only require 2 examples per category to train the first model. So now we have enough here. So you see it starts training. And otherwise, if you haven't uploaded the data, you can basically just annotate straight in the browser here.
Oh, that's saying like if you just dumped 100 images in there, you could go through yourself and be like mask, no mask, mask.
Yeah,
yeah.
So and we make it sort of trainer. Like, yeah, you can filter. Like right now, there's no all the images have a label, but you can basically filter on not assigned, and it's just you can very, very quickly go through. We've tried to optimize that. Okay, so now it's done. It's trained this model for you. And I actually put in an error here by mistake to be like, I guess, overly explicit. But this woman is obviously not wearing a mask. So Nyckel says no mask with 100% confidence, but we have actually labeled it as mask. So we can go ahead and fix that. And if you look at the accuracy bars here, as I'm fixing that, I fix it. And then the accuracy goes up, right? Because we fixed the ground truth and now it's retraining. And because the data is now better, all the other bars crept up a little bit as well. And then you can do things like you can look at these are like all the errors basically. So in this case, it's just 2 because we don't have that much data. So this one, Nyckel said it's incorrectly worn. And in this case, it says it's a mask, but it doesn't realize that it's incorrectly worn.
It's amazing as a human, you can look at those images and you could totally see why, like, the fact that there's 2 masks in the one picture, might complicate it. The fact that it's a very long mask, even though it's below the nose, that's pretty cool.
Yeah, exactly. And you can like filter on most confident, least confident, and so on. So yeah, I mean, so that's basically it. Then you just go to invoke, right? And then it's already deployed. This is deployed on a serious clusters. You can go to millions of invokes per day immediately. And then you just put in a new image, and I don't know if you even saw. I can do another one, maybe be a little bit more
it's quick, it's subtle.
Let's see here. So okay, so this one is unknown. This was not part of the test set, so I'm clicking invoke now, and there's the prediction.
Yeah, 99.87.
99.8 mask, and you can just copy this color request straight into your browser. Boom, and there you go. So then, obviously, if you want to go, everything I've done is as first class support in the API. So you can create image samples with or without labels. You can list all your samples. You can retrieve, delete, and so on. And the full docs are are listed here. So yeah, that's my little demo. So before I hand it over, let me just talk about a few use cases. So one of the ones I'm excited about is a developer in Ukraine are actually using Nyckel to categorize like the supply and demand for shelter for internally displaced refugees. So you have this site. This is a live site still, unfortunately, still live, where people can like basically offer shelter or seek shelter. And they had I don't understand exactly why, but they had a mix up in the database where people sort of they said they were seeking, but they were actually offering. They clicked the wrong buttons basically. So they use Nyckel to clean that up and figure out what is a request and what is an offer. And as you can see, the languages here is a mix of Russian, Ukrainian, and English, but we can manage that. This agency in Australia, it's again, the use cases are widely varied, right? It's a very generic tool. Spatial Sauce is a marketing agency in Australia that are making this sort of app where you can take a picture of a bottle of gin in the store and it'll recommend the right tonic for your gin and tonic. So they train a Nyckel function. They train a Nyckel function that can classify 300 different types of gin with like 99% accuracy. So I'm just, as a machine learning person, I'm really just excited about that. The fact that I worked.
Well, if you think about it too, like if I put my normal startup brain on and I wanted to do that company, it's like my first thing was like, we're not a machine learning company. What we're going to do is we're going to go hire interns to go through all the brands of gin in the world and like cram them in an Airtable or something like that and like identify them and this and that and everything.
Right.
And it's like I was going to do a ton of legwork, but here that's wild.
Yeah. So this is like, I think it's commissioned. So they are like an agency and it's commissioned by one of the big tonic makers, and they want to like recommend the right tonic for people. So yeah. Another one is Foregon. It's a Brazilian fintech company. I'm not including any user data here, but they are using Nyckel to actually spam filtering, like user validation. So people make sure that like when you create an account, you have to verify that you're a real person. So you upload a mugshot and they train a Nyckel function.
Oh, mugshot.
Yeah. To say if you're real or not. Oh yeah. And then we come to Gust. So I don't know if you want to say something more about it, Ryan, or if Peter's on the call.
I'll actually run through. While I was here, I was trying to go and find an example of the issue that we were dealing with. And I can sort of find an example, but it's working so well that I can't actually like show exactly it. But I will. Do you mind if I take over screen sharing from you?
Oh, yeah, of course. Thank
you. So this will be pretty crude because I couldn't get this super set up. But can you see a browser window with some Google search results?
Mm-hmm.
All right. So this isn't even Google. This is Brave. I use Brave, but whatever it was is what we started to find is, so Gust has been around for a very long time. We have literally hundreds of thousands of startup profiles on our website. So you heard me talk about Gust Launch. We have a whole separate division that we work on that like helps run companies as a SaaS-based thing to like give you best shots at funding, keep your corporate office back in good shape. But we have a massive SEO footprint about just startups in general, because we've been around for 15 or 16 years. And we have startup profiles that people use as a common application to angel groups and accelerators to just get resources on the early days. And so a startup will build a profile. Like if you look at Gust over here, they can publish it and they become available, and they can use it to apply to investors. They can upload a video. It's basically like a pitch deck, a digital pitch deck that you only have to kind of maintain once and apply to people. And so we have a whole database of these startups. And what's interesting is startups are so new and we've been around so long that our SEO footprint is so big that startups' Gust profiles show up before their website usually, because the way SEO works in the Google sauce is like backlinks and history and relevance and things like that matter. And most of what we're asking of the startups in the profile is super relevant things to their profile. So all good and nice. But what started happening in the last couple of years is we started ranking really high. This is bet 88. 88 is a very popular like gambling term to search on the internet. But you'd start to see Gust profiles for like strange things that are not startups at all. And these started to generate significant amounts of SEO traffic. And all of a sudden, startups, angel investing, accelerators, like best practices, those keywords were not associating with us. Random keywords for like super unrelated content were showing up and ranking very highly. And then we found there were entire SEO optimization websites encouraging people to go create spammy Gust profiles just to drive traffic to their site. Nothing that we want. And like I said earlier in the call, our initial approach to this was, we'll make a startup profile harder to publish. I'm not going to leak too much about how we did that in case there's any spam bots on the call who want to subvert our things. But we made you had to fill out more fields. We made it so that, if you put a link in your description, we like automatically blacklisted you. And we kind of fought back and forth with the spammers for, months and months, and they kept figuring it out. They kept figuring out how to do more fields and how to do this. And we're like, well, this could go on forever. And at some point, we literally get tens of thousands of people signing up every month. We're not going to manually review everything. So instead, we found Nyckel, and we literally just played in, just as the demo, in about 2,000 profiles that we knew were legit of startups, 2,000 that we've already marked spam through, our various things before and unpublished. And honestly, our first iteration was like 99% accurate. So, and what we did is we changed our software so that whenever a startup requests to publish themselves, we just ping Nyckel and be like, hey, here's all the fields on the startup profile. Does this look like legit or not? And the vast majority of the cases, like 99% accuracy, they can figure it out. If it's like duplicated text, if it's, URLs, if it's using certain language, if it's doing anything like that. But then what we also did was we have an admin interface, which I'll show really quickly, is anything that was a lower confidence, we just flagged as needs manual review. And now maybe 5 or 10 of these a week come through where we have to go and look. Like, this is a test company where if you look at it, it's like, oh, this is like clearly for some reason this tripped the thing up. It doesn't have as many fields as we need, but we use it to block our spam. And you can already see like we have saved ourselves so much time and effort. And like even this, that example I showed, this thing's already unpublished. Like I can't actually find a spammy profile that's indexed by search engines anymore that hasn't already been unpublished by the algorithm. And now we've just made it so that like, anybody who tries to publish, a profile just gets a quick check with Nyckel, and it's saved us one time hassle. And I think it's like, and when we do manual review, it sends it back to Nyckel to keep training the algorithm. So anytime there's like something starts to get anomalous, like, somebody's taking a different approach to try to get a spammy profile up there by like making it look half like a real business, but then putting a link to their, gambling website. I honestly, I haven't seen a profile that hasn't been caught. So it's pretty cool.
Wow, that's nice. We should charge you guys more.
Yes, you should. Yeah, I totally actually agree. You should.
Speaking of publishing on Gust, I haven't been able to get my Nyckel company profile listed. So I don't know if we get caught in our own spam filter. I probably
maybe the machine learning like knows. Yeah, that's amazing.
Yeah. I probably haven't hit the right button.
Well, you can reach out to me, and for a non-price raise on Nyckel, I will give you white gloved profile publishing for your Gust profile.
Excellent. Yeah, so I mean, we have 5 minutes. Is there any questions at all from the audience?
I don't see anything come in. I have a feeling a lot of people are fairly stunned by both the depth of the complexity of the domain, and hopefully as well as like the interesting solution you guys came up with. And I will say, is it Dan who is the API guy?
Yeah.
It is, it reminded me of not Grape, but whatever that auto documentary API thing, but integrating with this was like
Swagger, you mean?
Swagger, that's it. Yeah. It was like using Stripe in the early days, where as an engineer, especially as an engineer at a startup where we evaluated AWS has a machine learning component in their grid of 500 things that they offer. And we were just trying to take a look, and we looked at like setting up the VPC for this thing to run in, provisioning, learning about the things, this and that. It's just like, let's give this other thing a try. And it was literally less than one day. before we had a trainable function that we could throw stuff at. And it was a joy. I really like it. Awesome.
Thank you.
Striping. Yeah, cool. Perfect. I can feel it. And maybe I'm getting old because Heroku's probably an old startup by now. Heck, they're owned by Salesforce. It's kind of, don't meet your heroes, but yeah, it was pretty great.
No, it's been several iterations of us like discovering one of the big cloud providers, like Google has one called Vertex AI.
Mm-hmm.
When we first discovered that, we're like, oh my God, Google already has Nyckel. And then we were freaked out for a couple of hours until we tried it. And we're like, man, it's just so slow. And like, it just seemed like silly things that they're not doing. It's like silly UI things that are annoying. The machine learning takes hours instead of minutes. And also and then the APIs, like even for Dan, it's like very senior in this. It's like, why does it take me a whole day to figure out this API?
Yeah. I mean, this is a great case for startups. There's always opportunity for disruption.
Yeah,
like if you can apply a good user experience to a solved problem by other vendors, like that alone can give you years of runway away from your competitors. And some big ones, even the most innovative ones in the space, they move slowly. They have to go through OKR sessions to greenlight the team that will do the UX improvements on the thing that was a proof of concept a couple quarters ago. And it's really great.
Yep. Cool.
Awesome. Let me think if I have any questions, or if you have any questions about how we used even your own solution here.
No, I mean, it looked like there was a question coming through just now. Where can Nyckel be integrated in? Any restrictions? No, I mean, so right now we only expose it through the REST API. We've sort of been tempted to write SDKs in Python, C#, the popular languages, but we're resisting it because it increases the surface area of stuff we have to maintain, and it just increases the chance of something getting outdated and just behaving irrationally. So we have not done that. So the good news is that what we have is actually working as it should. The bad news is you have to write your own sort of wrappers, and I think it's only bad news if you're new at that. I think a lot of senior people prefer to just write their own API wrappers. But yeah, so that's one of the restrictions. The other restriction is that it's only available through an API. So we have a couple of customers that are interested in on device, model export embedded things. We've also stayed away from that because we're basically looking for a couple of really good beta customers so we can figure out how to do it the right way. So if you're one of those, definitely reach out and we'll add you. We want to have a couple of conversations because it's a very big design space on how to implement that. So when we do, we're pretty sure we have to do it at some point. We just want to do it right, quote unquote.
Yeah, I think one of the things I really liked about the way the API is laid out is it enables iterative development really quickly to do the proof of concept. Because for me as a consumer, the idea is machine learning made easy is a prove it value proposition, right? You think of it and you look at Amazon and you're like, oh my God, the amount of things I'm gonna have to string together and context I'm gonna have to hold in my head to do this. But the audacious goal of upload a bunch of CSVs and we'll give you an endpoint that you can hit that says yes or no is holy crap, I can do that in 20 minutes. And we had the data, and most people have data at hand. We had a ton of data at hand. We just downloaded a couple thousand things. We played it in, there was a function to hit. And then we just started playing in some profiles and we're like, this is great. So once we implemented it, we didn't even have a full model improvement. We just had the model with an endpoint to hit. And we're like, well, let's take a first pass at it. Anytime somebody tries to publish a profile, hit the endpoint. And there's 3 states. It's either auto approved, auto rejected, or needs review. And we let that run for a couple weeks. And then we learned a little bit and we're like, okay, this is working, but there's a couple edge cases. And for us, the most interesting edge cases were legitimate businesses building a startup profile that has no business being a startup. And these came from those SEO farms where it's oh, if you have a plumbers and pipe fitters, local thing, and you just want Google traffic, go just create a profile over here and you'll start to rank a little bit more than you would, because
you were part of that.
Okay. One person in a couple square miles or a small town or something like that. And those were the first ones where it's okay, the algorithm needed to not the algorithm, but the model needed to understand that like just describing what is a business accurately is different than describing what is, you know, a business that's going after investing, a business that has models. It's very different, and it worked. And that was where the improvement thing, where it's like, oh, okay, you know, this one's obviously spam, this one's obviously not.
Right.
And
Yeah.
like I said, now we're down to 5 to 10 manual reviews a week out of thousands and thousands of signups.
Do you verify the ones that are automatically accepted or rejected?
Manually verify.
Mm-hmm.
We did in the beginning, but we
Okay.
haven't had to in a while now that it's, I'd say we're probably like 4 iterations into just slightly improving it. And the really cool thing is the last iteration we did, we actually got to rip out, this is my favorite thing to do as a developer, a bunch of old code, because it turned out that we're confident enough now in the model that we don't need any of those pre-checks, you know, those things like fill out this many fields or do this kind of thing. Now
Right.
it's like we're kind of just using it,
Right.
you know, to reduce complexity, or to push off complexity into somebody else's domain, which would be
Right.
your job.
Still, I mean, you know, if you ask me, if I put on my machine learning researcher hat, I would be sleep happier at night if you took a small random sample of the ones you auto approve or auto reject and check them as well.
Oh, totally. I will do that for the fact that you spent the time with us today. I know this was probably the most technical talk we've given.
I mean, you know, I think it's probably, I'm probably just being paranoid, but machine learning can be so fickle, right? Sometimes the data shifts in a way that the model thinks it's really confident still, but it's wrong.
Yeah, need checks.
It's just one of those things. Yeah.
Paul Atkinson asks, can they get a document on the API and endpoint? Is that available on the site?
Or is it just... I think I just posted to everyone.
Oh,
maybe
there you go. That's you. Okay, sorry.
Yeah.
I had to scroll down a little bit.
Cool.
And to anybody asking, yes, we will send out a recording of this probably tomorrow. We'll wait till it processes and wraps, and, you know, screen it for vulgarity and things like that, because I was on the call. But yeah, we'll send that out. And Oscar, if you have anything that you want me to send people a link or resources or something where they can learn more, I can put that in the email as well.
Okay. Yeah, I think just a pointer to Nyckel.com is enough.
All right, here's the last question. Now we're a tiny bit over. Can machine learning be used to optimize thermocuffed fluid dynamics? I'm not even sure if I know what that is.
Yeah, I don't know what it is either. Thermodynamics. Yeah, I mean, you know, that's a whole industry. Like, it's, as deep learning is becoming more powerful, there's a lot of people in physics and biology and chemistry that are basically using machine learning to approximate a simulation done using like finite element methods, or like Monte Carlo, Markov chain Monte Carlo. So like a lot of these things, like thermodynamics, there is like a Markov chain Monte Carlo simulation you can run to simulate or optimize your situation, but each run is very, very expensive, right? It's extremely compute expensive. So what you can typically do is you do that a few times and use that as training data to train a machine learning model that approximates the behavior of the physical system.
Yeah, for anybody listening, Monte Carlo machines are used a lot, I guess, in finance, and apparently now in physics, where there are some problems that have like elegant mathematical solutions to them, like probability in terms of flipping a coin, right? You can flip a coin and you can model its probability based on what a 50-50 chance is, or you can flip 50 million coins and record the result every time to like intuit your way around a principle or an algorithm without necessarily having to do the real math of it. Now, obviously, probability theory has already been existed in thing, but there's so many different edges of science where just running the simulation can actually help you arrive at.
It's like the only way, because you can't you can't do it analytically, a lot of these things. So you have to just do these sampling methods. Yeah. Exactly right.
All right, Paul's got one last question, then we'll head out of here. Sorry to keep you a little extra. A recommended OAuth client. I don't know if that's super relevant to Nyckel background. As an engineer, we implemented our own. So use Gust. No, I'm just kidding. I know Vault and
yeah, I don't even know how to answer that question. Like, when I interface with Nyckel, the Nyckel API, I just write my own like thing that like refreshes the bearer token when it needs to, basically. I don't know if that's the question.
No, I think Paul, if you look into HashiCorp, I know they have some solutions around OpenAuth, things like that, but probably not terribly related to Nyckel and machine learning stuff.
Yeah.
Anyway.
Yeah, otherwise, in general, if you have questions, I'll type in Dan's email here.
There you go. Talk to Dan.
So just talk, as far as API goes, he'll be able to help you for sure.
Excellent. Well, Oscar, thank you so much. I know we had to reschedule this one, so I appreciate your patience with that. And
yeah, of course.
Honestly, this was great for me. This is one of the most technical talks we've had, and it was cool to go back into my history of an engineer. And I know it's a niche field for startups, but I do think it's a really cool thing. And thank you for everybody showing up, and Dan as well. I think the API is elegant, the result is good, and I will get you some validation information if I can steal some time when Pete gets back from vacation.
Perfect.
All right, so check out Nyckel. Be on the lookout for an email tomorrow with a recording of this and some resources from Oscar to learn more. And yeah, let me know. I'll also ask for just feedback on this because it is more technical, but we'd like to cover all aspects of entrepreneurialism and help. So give us some feedback if you can.
Cool.
Thank you, Oscar.
Thank you.
Yeah, have a great rest of your week. Bye, everybody.